So I am Ma'am Fortuna Familiaran. I am going to discuss week 4A of your math text. So this week topic is solving problems involving quadratic equations. So we are going now to apply in real life situations the applications of quadratic equations. Here are our guide questions. How are quadratic equations used in solving real-life problems and in making decisions? Real-life problems can be represented and solved using quadratic equations. These are conditions in a given problem which, when translated to the equations form, lead to a quadratic equation, and two possible answers can be obtained. Are all the roots of quadratic equations considered as solution for original equation? So sometimes we get negative answers, positive answers. So are they all the solution? In some problem, a set of answers can be discarded. For instance, negative dimensions, distance, time, speed, or age. This is known as extraneous solution. So meaning we don't have negative answers for dimensions, distance, time, speed, or age. Okay, we only get positive solutions. Okay, here are suggested steps in solving problems involving quadratic equations and rational algebraic equations. So first, we are going to read and understand the problem. Second, identify what is given and represent the unknown with a variable. So we are going to represent it with a variable or letters. Form an equation that accurately represents the given situations. Solve the equations. Fifth, check the solution based on the given conditions of the problem. And six, write the final answer in sentence form. Do not forget the unit of measurement if needed. Okay, so remember these 6 steps on how you solve problems. Okay, so here are the 3 problems that we are going to solve in this tutorial. So these problems are taken from your math packs. So everybody open your math packs and we are going to discuss and solve these 3 problems. Okay, these 3 problems are more on number problems. Okay, let's have example number 1. The product of 1 more than a number and 4 less than a number is 36. Find the number. Okay, so we are going to use variable to represent a number. Okay, let x be the number. Then, okay, it says here, the product of 1 more than a number. So we are going to represent this with an expression. Okay, 1 more than a number means x plus 1. Okay, then we have another one, 4 less than a number. Okay, so x minus 4. Okay, when we say 4 less than, okay, means we are going to subtract, okay, by 4. And then given here 36. Okay, what is 36? 36 is the product. Okay, so let's express this in an equation. Okay, so we have 1 more than a number and 4 less than a number. The product is 36. Okay, so we will use now the mathematical expression that we have. So quantity x plus 1 times quantity x minus 4 equal to 36. Okay, so this is now our equation. Okay, using FOIL method, okay, we have x times x, it is equal to x squared. Then x times negative 4 is negative 4x. And then we have 1 times x, it is positive x. And then the last term, 1 times negative 4 equals to negative 4 equal to 36. So we copy the right side of the equation. Now, after this, we are going to simplify the left side of our equation by combining the like terms. What are the like terms? Negative 4x and positive x. So it will be x squared, okay, minus 4 plus 1 will be negative 3x. Okay, copy na minus 4. And then remember, we are going to equate this to 0. So it means we will make 36 0. So we're going to add minus 36, okay, both sides of your equation. So we have 36 minus 36 is equal to 0. Then we are going to copy x squared minus 3x and then combine minus 4 and minus 36. So this will be minus 40. Okay, so this is now our quadratic equation. Okay, so from this equation, we're going to solve. Okay, solve for the roots. Okay, so given this, we are going to solve by factoring. Okay, now, what are the two numbers whose product is negative 40 and whose sum is negative 3? Okay, so what are the two numbers? Okay, it is positive 5 and negative 8. Okay, to check, positive 5 times negative 8, it is negative 40. Positive 5 plus negative 8 is negative 3. Okay, so these are now our factors. Okay, then we are going to equate this to 0. Okay, we are using zero product property. Okay, now, and then we are going to get the additive inverse of this number to make this 0. Okay, so we are going to isolate x. So positive 5 minus 5 is 0. Then we add also at the right side 0 minus 5. Okay, this will become x equals negative 5. Okay, then on the other side it will be, we add positive 8 both sides of our equation. So to simplify, x equals, okay, this one will be negative 5 and then this one is positive 8. Okay, so these are the roots of our equation. Now, we are going to check whether these two roots are solutions to your equation, to our equation. Now, so we are going to substitute. Okay, so if x is equals to negative 5, okay, we are going to substitute it to our equation. So by substituting the value of x, which is negative 5. Okay, so we are going to simplify. Negative 5 plus 1 will be negative 4 quantity, and then times quantity negative 4, okay, plus negative 5, it will be negative 9. So to multiply negative 9 times negative 4, it will be positive 36. So they are equal, meaning it is true. Okay. How about if our x is positive 8? So we are going to substitute again positive 8 to our equation. Then simplify. 8 plus 1 will be 9. Then 8 minus 4 is positive 4. Multiply 9 times 4, it will be positive 36. Okay, so if they are equal means it is true. So from this checking, after we check, we can say that the two values of x, -5 and +8, satisfy the given conditions of the problem. Thus, the number is either -5 or +8. So this is for example number 1. Okay, let's have example number 2. The product of two consecutive positive numbers is 132. Find the numbers. Okay, so when we say consecutive positive numbers, okay, they are in sequence, meaning pasunod. Okay, consecutive. Now, so example of consecutive numbers: 1, 2, okay, 2, 3. Okay, there are consecutive numbers. So we are talking here consecutive positive numbers. Okay, the product is 132. Okay, so we are going to represent the unknown with the variables. So let x be the first number, and then x plus 1 is the second number. Okay, then the product of these two consecutive numbers is 132. Okay, so from this expression, we are going to formulate our equation. Okay, we are going to formulate our equation. Okay, what is our equation? It says here that the product of two consecutive numbers. So meaning we are going to multiply the first number and the second number, and then we have our product. So what is our first number? So we use x. Okay, quantity, the second number is x plus 1. Okay, multiply these two, equal to 132. Okay, then we are going to simplify by using the distributive property first. Okay, so we have x times x, it will be x squared. Then x times positive 1 is positive x, equal to 132. Then again, we are going to transform this in standard form. Okay. So we are going to add both sides of the equation with negative 132. So what happened to the right side? It becomes 0. So this is now our standard form, which is x squared plus x minus 132 equal to 0. Now, so from this quadratic equation, we are going to find the factors. Okay, we are going to solve for the unknown value. Okay, now what are the factors of negative 132, and then the sum is positive x? Okay, so we are going to find the two factors. Okay, they are negative 11 and positive 12. To check, negative 11 times 12, it is negative 132. Then we are going to add negative 11 plus 12, it is positive x. Okay, then we are going to equate to 0. Okay, so after this, we are going to solve for x. Okay, so we have now these two equations. So the value of our x is, okay, this one, we are going to get the additive inverse. So it is positive 11. Okay, 0 plus 11 is 11. And then this one, okay, we get the additive inverse of positive 12, become negative 12. Okay, so 0 minus 12, it is equal to negative 12. Now, so these are the two roots. Okay, however, we are talking here to find two consecutive positive numbers. So meaning, okay, this negative solution is not uh, our negative roots is not the solution of our problem. So we can say that this is extraneous solution. Okay, we will disregard this. Okay, so we will use only positive 11 as our solution. So it means this is the first number. Okay, so how about the second number? Okay, so if x is equals to 11, so our first number is 11, then our second number is, okay, we are going to use this expression, x plus 1. Okay, what is the value of x? It is 11. 11 plus 1 equal to 12. Now, so 12 is our second number. So to check the solution based on the given conditions, okay, remember, okay, the product of these two numbers is equal to 132. So we're going to check 11 times 12, okay, equal to 132, which is true. So we can say that the two consecutive positive numbers are 11 and 12. Okay, so this is now our answers. Let's have example 3. The classroom contained 54 chairs. The number of chairs per row in 3 less than twice the number of rows. Find the number of rows and the number of chairs per row in a classroom. Okay, so this is our problem. So sometimes it is difficult to understand the problem. We have to read it again and again until you understand the problem. Okay, so let's have here the solution. Now, so supposedly, okay, this is now our uh, chairs. Okay, so if we look at here, there are two rows. So magambal kita row, this is row 1, row 2. And row 1, okay, we have several chairs. Row 2, there are several chairs. Okay, now, so let R equal to number of rows. Okay, so we don't know yet. Okay, well, how many rows? Now, then we have here 3 less than twice the number of rows. Okay, so how are we going to express that? Okay, 3 less than twice the number. So when we say 3 less than, okay, minus 3. Twice the number, 2 times. Okay, so it is 2 times twice the number of rows. So 2r minus 3. Okay, this is number of chairs per row. Okay, so how many chairs are there in each row? Okay, then we have 54 chairs. Okay, this is the number of chairs. So let's express this into equations. So we have number of chairs per row times number of rows equal to number of chairs. Okay, so like in a classroom setting, we are going to arrange the chairs. So how many chairs are there in one row? Okay, and so on. Okay, so we have here, okay, using distributive property, 2r times r is 2r squared. And then negative 3 times r is equal to negative 3r equal to 54. And then we are going to write this in standard form. We have 2r squared minus 3r. Then we get the additive inverse of positive 54. It is minus 54. Okay, we add both sides of the equation. So our standard form now is 2r squared minus 3r minus 54 equal to 0. To solve again, okay, by factoring. Okay, so what are the factors of these two numbers? Okay, so we have quantity 2r plus 9 times quantity r minus 6 equal to 0. Okay, so we're going to check why is it this. These are the factors. So the two factors of 2r times r, and then the factors of negative 54 are positive 9 and negative 6. And then we're going to check the middle term. Okay, so we have, when we check the middle term, it is outer term times inner term. Okay, so 9 times r is 9r, and then 2r times negative 6, it is negative 12r. Negative 12r plus 9r, we have negative 3r. So meaning these factors are correct. Then we are going to equate this to 0. So we are going to solve for the value of r. Okay, the first one is r equals to negative 9 over 2. Okay, so we get the additive inverse of positive 9. Okay, that's negative 9. Okay, divide both sides by 2. Okay, so we have r equals to negative 9 halves. And r, okay, this one, r minus 6 equal to 0. Okay, we get the additive inverse of negative 6. So it is r equal to positive 6. Now, if we look at our roots, okay, so remember we are going to get the number of rows of chairs. So meaning we are dealing with positive numbers. So this roots is an extraneous solutions. So we only get positive value, which is r equal to 6. Now we are going to check if r equals to 6 satisfy our equation. So again, we will get our original equation, then substitute, okay, the value of r, which is 6. So simplify. 2 times 6 is 12. 12 minus 3 is equal to 9. 9 times 6 equals to 54. So 54 equals to 54 is true. Now, so from this, we can say that the classroom has 6 rows of chairs, and each row has 9 chairs. Okay, so there are 9 chairs and each row, and we have 6 rows. Okay, to have 54 chairs all in all. Okay, so this is for problem number 3. I hope that you learned something from this tutorial. So, God bless everyone. Bye-bye.